Hi viewers, I am Akansha and welcome back to my YouTube channel. I am a PhD scholar of IIT Patna and I have done M.tech from NIT Jalandhar. Today I will talk about combinational circuit, sequential circuit and detailed description of SR flip-flop. What is combinational circuit? Let us discuss with block diagram. The output of combinational circuit depend on present input only. The combinational circuit perform a specific information processing operation fully specified logically by set of Boolean functions. The combinational circuit consists of input variable, logic gates and output variables. The block diagram of combinational circuit is shown in figure. The n input binary variable come from external source and m output variable go to the external destination. These are some examples of combinational circuit. Half adder, half subtractor, look ahead, carry adder, priority encoder, multiplexer, demultiplexer. What is sequential circuit? It is a block diagram of sequential circuit. Sequential circuit are those whose output levels at any instant of time depend on not only on the level of present input at that time but also the state of circuit, that is on the prior input level condition, means past input. The past history is provided by feedback from output back to the input. It means that the sequential circuit has a memory. The sequential circuit are thus made up of combinational circuit and memory elements. These are the some examples of sequential circuits: counters, shift register, serial adders, sequence generator, logic function generator. Let's discuss comparison between combinational and sequential circuits. The output variables at any instant of time depend only on present input variables. In contrast of sequential circuits have output variables at any time dependent not only on present input variable, also present state. Input in combinational circuit, memory unit is not required. In circuits, memory unit required to store past history of input variables. In combinational circuit, these are faster because the delay between input and output is due to propagation delay of gates only. But sequential circuits are slower than combinational circuit, and combinational circuits are easy to design. There is no complexity at all. In comparison with combinational circuit, it is harder to design. To understand the flip-flop, we need to know NAND Gate, truth table and some functionality of NAND Gate. If we give input 0 0, then we can get output 1. If we give input 0 1, then we can get output 1. Then if we 1 0, then we can get output 1, and if we give input 1 1, then we get output 0. But when we apply 1 and we don't know about x, whether it is 0 or 1, then we can get output x bar. We can understand by this table, when input 1 1, we don't know about x. What is x? If x is 0, then we can get output 1, means x bar. If we give input 1, then we can output 0, it means x bar. Then it is verified from this table only. Second, if we give input as 0, then we don't know about x, whether it is 0 or 1. Then we can 1 and 1 only. So it is verified by truth table. So SR flip-flop. The SR flip-flop stands for set and reset flip-flop. It is a block diagram of SR flip-flop. There is an input of S and R. Then flip-flop have clock as the input, and there is a clear and preset. Q is present state of flip-flop and Q bar is inverse of Q. If you are watching till now, so please subscribe to my YouTube channel, then you can get latest job update and subject related videos. It is a circuit of SR flip-flop. There is 3 input as S is R and clock. Firstly, when we give S is equal to 0 0, then you can get as output as 1 and 1. Here we can consider as Qn as input. In bottom NAND gate, we can find as output as Qn bar by previous discussion, and in above NAND gate, here is Qn bar and here is 1, then we can get as output Qn. So in final we find that Qn. Here is second condition, S is equal to 0 and R is equal to 1 and clock is also 1. Then we can get as output of above NAND gate as 1 and below NAND gate as 0. Here we can consider as Qn. So bottom NAND gate gives output as 1 by previous discussion. Here in above NAND gate as 1 and 1, then we can get output as Qn is equal to 0. So S is equal to 0 and R is equal to 1, then we can get as output is 0, which is reset of input. Third condition, if S, it will be R. Then we can get as in above NAND gate, we can find as output is 0. In below NAND gate, if we give input as 1 and 0, then we can find as output 1. Then firstly consider as bottom NAND gate, and here we can consider as Qn as input. Then if we give bottom NAND gate input as Qn and 1, then we can find as output is Qn bar. Here it is Qn bar and here it is 0. Then we can find as output of above NAND gate as 1. So if it means it is set the input. Next, when we give S is equal to 1 and R is equal to 1 and input of clock is also 1, then in both NAND gate we can find as output is 0 and 0. Firstly, we can consider bottom NAND gate. Here we can consider as Qn. So the input of bottom NAND gate is Qn and 0, then we can find as output as 1, and here it is 1 and here it is 0. The truth table of NAND gate we can find as it is 1, but it is invalid state. Here is also 1, here is also 1, but it is inverse of this, so it is not possible. So when we give S is equal to 1 and R is equal to 1, then we can get output as don't care or invalid state. It is truth table of SR flip-flop. If we give SR is equal to 0 0, then we can get output as previous state. If it is 0, then we can get 0. If it is 1, then we can get 1. But in second condition, when we give input of SR flip-flop is 0 and 1, whatever state here it is, then we can find as output as 0, means it is reset of input. If we give SR as input 1 and 0, then whatever state there input is there, then we can get output as 1 1, which is set of input. Input as S is equal to 1 and R is equal to 1, then we can get a invalid state. It is a characteristic equation of SR flip-flop. If we give S and R is equal to 0 0, then we can get previous state. If we give SR is equal to 1 0, then we can get set state 1 and 1. If we give SR is equal to 0 and 1, then we can get output as 0 and 0. If we give SR is equal to 1 and 1, then we can get as don't care. So we can group 1 1, and this is also a larger group. So in K-map we consider this as a first, and we can make another group of 1 and 1 of 2 members. Output of this is S, and minimized equation of this is Q and R bar. Sorry. It is excitation table of SR flip-flop. We can find excitation table from truth table of SR flip-flop. The output of truth table is input of excitation table, and input of truth table is output of excitation table. So firstly consider 0 and 0, then we can get as S is equal to 0, R is equal to don't care, and when we give 0 1, then we can get as output 1 and 0. After that, when we give input as 1 and 0, then we can get output as 0 and 1. After that, final is give input as 1 and 1, then we can combine two state, which is in S there is don't care, and in place of R it will be 0. So we can find the excitation table of SR flip-flop by help of truth table of SR flip-flop. This is enough for today. Hope you guys enjoyed it. And thanks for watching my channel. Don't forget to like, share and subscribe to my YouTube channel. Thank you.